Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Okay, so welcome to my video. So basically this is a continuation of the lecturer video for chapter 1, topics basic concept of electric circuit. Okay, so this is actually a part 3 video where we are going to cover a subtopic of energy and power. Okay, so if we recall from the previous video, we had covered subtopic 1.1 until 1.3 in the video part 1, and then we had covered for the subtopic 1.4 in the video part 2. Okay, so in this video, we are trying to see what is the definition for energy and power, and then what are the relationship between these two parameters. Okay, alright, so let's have a look. What is the definition for the energy? Okay, so basically energy is the capacity to do work. Energy also can be defined as the rate at which power is used in a certain length of time. So meaning that it said that energy is equal to power multiplied with T. Okay, alright, so symbol for energy is usually we use W, and then it is measured in joule, right? And then the electrical energy used by the consumer is measured in watt hour or kilowatt hour, where 1 watt hour is equal to 3600 joule. Okay, so the relationship between energy and power is given by energy is equal to power multiplied with time. Okay, so usually energy we write it in term of symbol W. Power we write it in term of symbol P, and then time is in symbol of T. So W is equal to P multiplied with T. Okay, so let's say you are given energy is equal to 3600 joule. So it is also equal to 3600 watt multiplied with 1 second. Okay, so we can further simplify it to become 1 joule is equal to 1 watt second. Alright, so as you might recall from the previous slide, we said that the energy that being used by the consumer usually we put it in term of watt hour, right? So the energy for watt hour is equal to power watt multiplied with the time is in term of hour. Okay, so how about for energy in term of kilowatt hour? So the energy for kilowatt hour is equal to power in term of watt multiplied with time in term of hour over 1000. Alright, okay, so next we go to the subchapter of power. Okay, so power is actually the definition of power is defined by the rate at which energy is used. Okay, so meaning that the symbol for power is P, and then it is measured in units of watt, or maybe you can just use joule per second. Okay, so in the other word, okay, the power can be defined as a certain amount of energy being used in a certain length of time, and then we can express it by P is equal to W over T. Okay, so we know that W is over T is also equal to W over Q multiplied with Q over T. Okay, here you can cancel Q and Q. Right, so W over Q is also equal to V, and Q over T is also equal to I. So that's why you get P is equal to V multiplied with I, and then the units for P is equal to watt. Okay, so 1 watt is also equal to 1 joule per second. Okay, so 1 watt is equal to 1 joule per second. So unit of power in the British engineering system that we use is a horsepower, where the 1 horsepower is equal to 746 watt. Alright, so the mathematical relationship of the time varying power is given by P is equal to dW over dt. Okay, so where power is in watt, W is in energy joule, and T is in term of second. So if the power has a positive sign, it means that power is being absorbed by the element. Okay, if the power has a negative sign, it means that power is being supplied by the element. So that's why later on when you try to calculate the power at resistor maybe, so when you get a positive number, so it means that the resistor is actually absorb the power. And then let's say you want to calculate the power at the source maybe, so when you try to calculate and then finally you get the value of the power is negative, so it means that the power is actually being supplied by that particular sources. Alright, so later on we are going to see in detail on how to calculate it. Alright, Okay, the relationship for power is also can be given by P is equal to I multiplied with V. Okay, so current multiplied with voltage is also equal to power. Okay, so the passive sign convention is satisfied when the current enter through the positive terminal of an element. So this is what we call as a passive sign convention. Okay, so let's say you have a P equal to plus IV, so meaning that you have a element, and then the current enter through the positive terminal and then coming out through the negative terminal. So the power is equal to positive IV. So it means that element is absorbing the power. So remember, if the number is positive, so it means that element is absorbing power. Right. So how about if the current enter the negative terminal? Okay, so if you have like this, okay, so the current from here and then coming out from here, and then it means that it enter the negative terminal, coming out from the positive terminal. So P is equal to negative IV. So when your P is negative, so meaning that element is supplying the power. Alright, so this passive sign convention, you must always remember, okay, you must know the definition, because you are going to use it over and over again when you are trying to calculate the power, whether the power is absorbed or the power is supply by that particular element. Alright, okay, so now let's have a look at the following example 1.5. What is power in watts for an amount of energy equal to 100 joule used in 5 seconds? Okay, so in this question, the energy given, so the W is equal to 100 joule, and then the time is 5 seconds. So you know that power is equal to W over T. Okay, so your W is 100, T is 5, and then 100 over 5. So P is equal to 20 watt. Right. So for the next example, okay, let's say you have a 12-volt battery is connected to an electric circuit. So determine the power supply by the battery if 10 milliampere current flows through the circuit. Right. So you have V is equal to 12, and then you have I is equal to 10 milli. You need to determine the power, right? So P is equal to I multiplied with V, so I is 10 milli, V is 12, and then you just substitute, so you get 0.12 watt. Okay, so this is easy peasy, right? So second question, a 4-volt DC voltage across an electric element used 30 joule energy within 5 minutes. So meaning that your W is equal to 30 joule. And then find the current passing through the elements. Okay, for this question, you need to find I. But before that, you need to find the P first. Okay, so P is the power, right? So V is equal to 4 volt. W is equal to 30 joule per 5 minutes. So P is equal to W over T. So W is 30. Then divide by T is 5 minutes. So 5 minutes is equal to 60 over 5. Okay, because here is your T is in term of second kan, but the question give you in term of minutes, so that's why you need to 30 divide by 5 multiply with 60. So P is equal to 0.1 watt. Alright, and then after that, once you get your P, now you can find what is the value for current. Okay, so I is equal to P divided by V, and then P is 0.1 divide by 4. Okay, 4, and then I is equal to 0.025 ampere, or you can use the prefix so that you can have 25 milliampere. Alright, okay, so the next example, okay, a 60-watt light bulb is set to be turned on for 364 days. Determine the total energy in kilowatt hour. So you are given P is equal to 60 watt. Okay, T is equal to 364 days, and then now the energy of W is equal to what? Okay, so from the previous slide, we know that the formula for energy in terms of kilowatt hour is given by power multiplied with time in terms of hour over 1000. Right? Okay, so W is equal to PT over 1000. So P is equal to 60 watt. Again, T is in term of hour, right? So here you have 364 days. So you need to change it into become hour. So you have 364 day multiplied with 24 hour over day. Okay, and then after that, you just use your calculator, get the value, and then you can have the final answer is equal to 525.6 kilowatt hour. Okay, so this is the total energy that been used by this light bulb for about 1 year, right? Okay, So next question. A 5 horsepower motor is operating for 2 hours. Determine the cost that need to be paid if the tariff rate is 90 cents per kilowatt hour. Okay, so for this question, P is given by 5 horsepower and T is given by 2 hours and tariff is 90 cents per kilowatt hour. So that's why in order to determine the cost by using this tariff, we need to change the power in kilowatt hour first. Okay, so W is equal to PT over 1000. Okay, so this is the formula. So now P is given in terms of 5 horsepower. So from 5 horsepower, you need to change it to become in terms of watt. So you know that 1 horsepower is equal to 746 watts. So that's why 5 horsepower multiply with 746 watt over horsepower. Okay, so horsepower can be cancelled. Alright, and then T is equal to 2 hours. Okay, so just multiply with 2. Okay, so finally you can get the final answer is 7.46 kilowatt hour. Alright, so for the tariff used, it said that the tariff rate is 90 cents per kilowatt hour. So for this kind of energy being used for 7.46, we need to determine the cost. So cost is equal to 7.46 kilowatt hour multiplied with 90 cents per kilowatt hour. So kilowatt hour and kilowatt hour can be cancelled. So finally, the final answer is 67.14 cents. Alright. So that's all for now. Thanks for your time and thanks for watching. I'll see you in the next video. Bye.